Good morning students. So welcome back to Digital Electronic class, Unit 3. In today's class we are going to discuss the concept of basic configuration of PLDs. So basically what is a PLDs? PLD stands for Programmable Logical Devices. It consists of three parts in it. One would be the ROM, second would be your PLA, third would be PAL. So that thing we are going to learn the basic configuration of PLD. Before proceeding for today's class, let us consider the overview of previous class. In previous class, we done with problem based upon your programmable logic device by considering what? By considering the PROM. We did one problem, right? So problem we talk about for ROM. So in today's class, we are going to discuss the basic configuration of this PLDs. It has how many parts? It has three parts. It consists of three things. One is ROM. That is nothing but PROM. So what is P stands for? Programmable Read-Only Memory. Next thing we do have PAL, Programmable Array Logic. Next we had PLA, Programmable Logical Arrays. So these three concepts we are going to discuss in today's class. So in that, what is the first thing we are going to discuss? We are going to discuss about PROM. How do we configure the PROM? So in order to configure PROM, what is PROM stands for? Programmable Read-Only Memory. So programmable read-only memory we do have. So we are going to done. We just want to start the PROM. So in that, what is the first thing we are going to see? We are going to see its block diagram. So that block diagram consists of fixed and array decoder and programmable OR array. So what actually it consists of? When we are giving any input, suppose I do have a block diagram like this. What I'm giving my input value. So when I'm giving input, so what I do have here, I do have two types of it. Two types of gates we do have. One is for OR gate and another is for AND gate. So then we're going to get the output over here. Right? So when we want to go for input value, so what is the input value I do have? I had the first input, what I'm giving for the input? Fixed and array. So what I'm giving here? Here I'm passing with the fixed. What type of array? AND gate arrays. So fixed and array. Here what I'll give? I'll give OR. But here I'll not mention it's a fixed. So what I'll mention? Only I'll mention programmable OR array. So here I'm doing programmable. So programmable OR array. Right? So when I'm doing this kind of arrangement, when I'm making the AND gate is fixed. Array in the sense it's not a one gate, it is a different types of same type of AND gates, but it used in multiple times. So that then is considered to be the arrays. Similarly, here what I can write, I'm programming. I'm just doing the programming over there and just want to store in OR gate. So this is what? Programmable OR array. So this is the first part for configuring PROM. Similarly, I'll need to proceed with second part. What is the second part I do have? I had is PAL. Right? In PAL, what is the same thing? I need to make a blocks of it. So what I'll do it? I'll first make one block in this. So input I'm giving again, and I'm passing with one more block and want to produce the output of it. So for producing this PLA, what is PLA stands for? Programmable Logical Arrays. PAL stands for Programmable Array Logic. So what is this I'm writing here? Here I'm mentioning programmable array logic. So in this also one particular part would be fixed, another part would be what? Program. So in this one, the previous one we did program. Here what will be? Programmable AND array and fixed OR array. So here programmable AND array. Right? What about this side? This we are considering to be the fixed OR array. It's quite reversed when compared to this PROM. So as you can see here, so input whenever you are giving AND array is okay, but the thing is here we are doing the programming part. So that particular thing, when you want to design that PLD, that is also one of the example of PLD, right? So this is the thing which we are doing the programming. So that we are passing to the fixed OR array and we are going to get the output over here. So that is nothing but the PAL. Then third thing is what? PLA. What is PLA stands for? PLA stands for Programmable Logic Array. programmable logic array. So in this also again we use two things, but here there is no fixed part. Both the things are programmed, means programmable AND array, programmable OR array. So whatever the things we are using, both are programmed, not the fixed. Okay, so this is a connection, this is our input we are giving. So this end we do have input, and this end we are just want to get the output. Okay, so this is also programmed. So this I can say programmable AND array. This also programmable OR array. Okay students, so we just discussed three parts in PLD. So both are programmable AND array and programmable OR array, that considered to be the PLA. So right now what is the concept we are discussing? We are discussing about basic configuration of PLD. It consists of three parts in it. One is the PROM. That PROM is nothing but what actually use of ROM actually. ROM, what is the use of ROM? It's a memory element. It is going to store the information and only for reading purpose. We cannot insert anything in it. Whatever the data we do have, it is used for permanent part. Excuse me. Whenever we want to go for PROM, in that what is the ROM stands for? It is nothing but memory element or memory latches. What is the use of it? It is going to store a data. For storage purpose, we are going with PROM. So in that first part, it is nothing but fixed AND array. When we are giving input, here we are doing fixed. Whatever the AND arrays are there, AND array in the sense, whatever the AND gates we do have, we are using multiple AND gates. As you can see, we pass with multiple AND gates and we'll connect with all the functions. We'll produce here some function. This is our what? These are fixed. So when we are saying it is fixed, it is passing to another gate, that is nothing but OR gate. So here we are programming and then we are producing the output, then it is called PROM. Second thing, PAL. In that what I am doing, one is program, second thing is fixed, like a vice versa for the PROM and PAL. What about this PLA, programmable logical array? In that what I am doing, both are programmed, AND gate as well as OR gate, both we are programming and we are just going to get the output when giving the input combination. It is also one of the type of PLDs. Let us consider one problem, students. So what we are doing, we just want to go for some numerical for PLA. So in that the question is implement three inputs. Implement three input Boolean functions f1 is equals to ab bar, f1 is equals to a b bar plus AC plus A bar B C bar. This is the first function, and second function F2 is equals to AC plus BC whole complement or bar, we can say. It's a whole bar, right? Using PLA. Logic. Okay, so here they get you by using the logical gates, not by using this conventional gate. So in that PLA we have to use. What is PLA stands for? In that programmable AND array and programmable OR array, both are programmed. So how do we implement that one? That I'll show you. So what I'll do it, I'll take three inputs. First I'll take A input, I'll connect with one NOT gate. So like this I'm giving connections. What is this indicates, students? This is nothing but A, means this is A complement, this is A, right? This is my A. Second, I need to get the B. So this is one B and B complement. So this is your B complement, this is one line B. So this way also you can represent the NOT gate. This is called buffer. Okay, similar to NOT gate. What is the NOT gate actually? We will put one line and we'll give like this, A and A complement, right? So this A, instead of that side, I am writing here A. The line which don't have bubble, bubble is there means it's complement. So similarly B, and similarly I'll go with C. Bubble I'll put here. This is C complement, this is C. Giving input C. So put a lines over there. Whatever we got, A, B complement and C complement we found. Now next thing is that we have to make a lines of it. What I'll do it? I'll extend, I'll put a line like this. This is for A. This is for A complement. Likewise it is there for B and B complement. Like it is there for C and C complement. Right? So we put a lines. Next thing, what is the next thing is required? We have to give the first logics. What is the, how many AND gate we required? All are programmed, right? PLA stands for programmable AND gate as well as programmable OR gate. For that, what I will do it, we will put like the symbols 1, 2 and 3. And we will put what? 3. I'll draw the little bit below so that it will be easy for me to get all the gates. Instead of there, a little bit put it down. So I'll put like this 1, 2 and 3. I'll put one straight line for this also, for this also and for this also. So programmable means cross mark you have to give. What is the first I need to get for F1? I need to get A and B complement. For second one I should get AC. For third I should get A bar, B and C bar. So what is A? A line is here. This is one cross mark. Then it is B complement. B complement is this. Right? So this is my first connection, I got it. Similarly for AC, what is A? Here is A. And where is C? Here is C. Right? That is also we give the connection. Clear? Next thing, A bar. So where is A bar? A bar is here. Next B. We do have to take the B. This is your B with connection. Then we have C complement. This is your C complement connection. Right? So what we done, students? So we took and all are program. How do we say it's program? Cross mark indicate it's a program. Okay? That you have to keep in your mind. If I put a dot, that means it is fixed. So we have not done any fix because in PLA we don't have fixed element. We only had program. That's the reason we are giving the program element in this way. So we got the 3 connection like this, right? Next thing, after getting the connection, what is the next thing we should have to write? We have to extend these lines and we'll write here A, B complement, AC, A complement, B and C complement, right? So next thing, I need to add all these things. So for adding, what I'll do it, I'll take, I need to get one more, right? For second part, I need to get BC also. Because F1, F2 I'm doing simultaneously. AC already we do have and I need to get BC. So for that what I'm doing, I'm taking one more connection here. What I'm writing for this, B and C. So BSC is not possible here, so I'll draw a little bit down. This side I'll draw it. So F2 also I do have BC, right? So BEC. We'll put one line. Where is B? Here is B. Where is C? Here is C. This is your BC. Now I want to generate for F1, one OR gate, right? I need to generate for F2. So I'll put one more OR gate like this, right? So simultaneously I'm doing, so I'll draw here. So first thing, I have to get one F1. For that F1, I'm connecting addition of all. That's what? One OR gate. For F2, first addition. Then we'll connect one OR gate. So F1. So what is F1 first value? AB bar. So where is AB bar? Here I do have AB bar. I'll put across. Next I had AC. Where is AC? This is AC line. I'll put across. Next A bar, BC bar. Here I do have. So this is my F1. Right? For F2, to get F2, I have to first get the complement. We don't have complement. I'll take the complement later. First what will take F2 value? AC plus BC. AC and BC. Right? Next thing, I need to get a complement. For a complement, what I'm doing, this I can connect one more buffer. What is that buffer indicates? I can go with buffer. For that, what I'll give, instead of this cross mark, I can connect a separate one input here. Not input, I can connect from this end one NOT gate. What is the NOT gate means? Like this, I can connect one buffer and I can produce the F2. Clear? This is one way. Second way what we had properties. x exclusive OR with 1 is nothing but x complement, x exclusive OR with 0 is nothing but x. That means by using this property, either I can connect one NOT gate, so this F2 is answer, I can get it as AC plus BC whole complement. But as per this PLA, we cannot connect like separately, because all our program, cross marks indicates all our program. For that, what we can give, instead of this NOT gate, I'll give one exclusive OR. Exclusive gate I'll connect, I'll mention one is 0, another is 1. So what I'm doing, I'm passing with the exclusive OR. So when I'm putting with exclusive OR, so what is the input connection I do have? Input connection I'm giving from this line. This line is passed here. So what is that line indicates? That indicates like this I'll pass. Suppose I had like this, exclusive OR, right? So what is the answer of this till here? It is, whatever the answer is here, suppose this is your 1. 1 I'm passing to this. Another I'm giving exclusive OR gate to second part for this input. For this input I'll pass one more exclusive OR. So 0 exclusive of F1. So 0 exclusive of F1 is F1 only, right? 1. So 0 exclusive of F1 is what I'll get? F1, because we don't want to take complement. Do we have whole complement in this? No. So 0 exclusive of F1 is F1. 1 exclusive of F2 is F2 complement, right? That's what I'm passing this with 1, this I'm passing with 0. So what I'll get here directly, here I'll get exact answer of F2. So what is F2 answer? AC plus BC whole complement. So only tricky point is here only, students. So remaining are exactly same as the previous one. Why I connected to exclusive OR gate? Because of this relation. So once again, see students, so it is what actually we are doing. We are taking PLA, logic designing. In PLA, what is a PLA? Just now we see the block diagram of it. Fixed, we don't have any fixed in PLA. Only we had program and program OR. For that, we gave 3 inputs. So for the A1, we have to get this. So we connected this 3. Initial 3 AND gate is there for F1. And this one more is there for F2, BC. BC and AC, we connected to F2, right? So F2 exactly we don't get the whole complement. For getting the complement, this has been used. Why we are using this? Because x exclusive OR with 1 is x complement. We had this property. You have to remember this property for exclusive OR. Okay. X exclusive with 0 is x only. For using these two properties, I want to get complement for F2. For that, what I need to give? I need to pass with 1. So that I am giving, this is my separate logic. Separate input I am giving. Because I don't have further values, no? So I am giving the separate 0 and 1. So 0 I am giving with first F1. If I don't have this complement, no need of using this whole thing. Here only our answer will be over. F1, this is your F2. But since your complement is given, for that purpose, we are connecting one exclusive OR. Here we don't require it actually. Because F1 directly we got it. But in order to explain you, in order to get some problems, in some problems you may require both exclusive OR. For that I have given these gates. Okay, this gate is not necessarily you have to give connect only. It is only for our understanding purpose. I have passed. Clear? So 0 exclusive OR with F1 is F1. So that's what it's F1 only. F2 exclusive of 1 is F2 bar. Because we have to get this bar, right? This bar of the function, whatever the values. So for that one, instead of F2, what actually our expression is? AC plus BC is there. So what I can write for this function I can write? AC plus BC whole complement. Because of that, AC plus BC exclusive OR with 1. So this is your exclusive OR gate. So this is your exclusive OR gate. So that's what we got F1 and F2. This is the way we will do problems related to PLA, PAL. We'll see in the next class. For today's class, you remember this diagram and practice this problem as many times as you can. Thank you. Note down this property also.